Hey, just want to go back over what we were talking about today in class. This is Module 4, talking about the dial caliper. I brought one of the calipers that we were using in class, and remember this one, the dial just goes to 50. Even though it goes to 50, we're just going to assume this is 60, 70, 80, 90, 100 as we go around. This caliper measures 6 inches. It'll measure just a little bit over 6 inches if we need it to. This is our 1-inch dimension here. It has to go past that point for us to be able to actually get a good dimension off of it. So as we come in, we can kind of zoom in here, see the motion on this caliper, how it works. So this is 100 thousandths. It doesn't become 100 thousandths or more than that until you see this line right here. 200 thousandths, 300, all the way up to 1 inch. Anything after 1 inch, what the caliper is reading right now is 1 inch, 100 thousandths, and then another 15, 17 thousandths after that. So we are at 1 inch, 117 thousandths on this particular 6-inch caliper is what it's showing us. So I'm going to go ahead and take a couple of quick measurements on the part, and just so we can see what we've got, make sure that we're reading and understanding the caliper. The print for the part is on here. We've got our tolerance block down here. That tells us what we're working on and what we can get away with tolerance wise. So our stock is 2 inches and about 11 thousandths is what is reading here. So there I have 2 inches. It's past the line there, 2 inches. Now we're all the way over here. That's 5 thousandths, 10 thousandths, one more. That's 11 thousandths. So on our part, this dimension is 2.011. So 2.011, we have a 2-place decimal. The 2-place decimal has plus or minus 5 thousandths tolerance on it. And that tells us this is already out of print. So this dimension is out of tolerance. So we look at our 1-inch dimension. Our 1-inch dimension is also oversized, and that's really common when we're talking about stock. And it is 1 inch, 111 thousandths as well. So we come back in here, take a look at that, and 1 inch, 111 thousandths. Saw length on this. This thing's supposed to be 4 inches long. It's just sawed to length. So we are way long on this. This scale, we're going to read it at 4 inches. We haven't surpassed the 1 yet. So 4 inches, 50, 60, 70, 71, 2, 3, 73 thousandths. So 4 inches, 73 thousandths for that dimension. Remember, we're always talking in thousandths. So as I read that, I've got 4 inch, 73 thousandths is how I would read that. Take a couple quick measurements of our holes just to give you the idea of measuring inside with this. Measure my hole. It is come up here. It's supposed to be a 3/8 hole. 380 I think is the dimension on it. So as I come up here, I have not went past the 400 yet. I can see the line for the 3. This is 3, 50, 60, 74, 374 for the hole. That was probably done with the 3/8 drill, so it's really probably 375. Remember, on our calipers, we want to try to stay within about a plus or minus 5 thousandths dimension on that for calipers. Don't want to try and hold 1,000 tolerance on that. So we're just using this as a reference on this. This is not something we want to take a lot of critical dimensions where we might be measuring in 10 thousandths of an inch or even 1,000th of an inch. So I can measure my slot width. Slot width is supposed to be 1/2 inch. I'm dead on 1/2 of an inch here. So 500 thousandths is what that is, and then I had 500 thousandths or 1/2 of an inch. Last thing I want to measure is I want to show you a couple different ways that we can measure the depth. The depth of this slot right here should be 50 thousandths. I can do it a couple different ways. I can come in here and I can take this backside edge, set it down into the slot, measure it this way, 39 thousandths. I can come down here and I can measure it this way. So I'm spanning the slot. And I'm just going to pull it down. So there, come back over here, measuring just a little bit differently here, a couple thousandths difference in there. Another way I can do it is to take the overall thickness of it, then measure the depth of the slot, and then I can come in and about the same, pretty close. Remember, the bottom of this thing is not machined, so it's not going to be perfect. It is short though, so we're at 39 thousandths, I think is what we were. Should be 50, so we're 11 thousandths out on that. So that's, again, not a good part. When we're checking for our hole spacing, so this hole spacing should be 1 inch, 2 inch, 3 inch. Coming from the side, we want to be able to measure to the center of the hole. So I can come in here and, yeah, I can eyeball this to the center of the hole. That's one way to do it. But if I want to be close on my measurement, I want to measure over to the edge, add the radius of the hole. That'll tell me where the center point is. On these, there's going to be quite a variation on there. Just saw cut on the side. Remember, we just made these as some sample demo parts that we were making for some other projects, just to give some people an idea of what the CNC mill looked like. All right, so remember, when we're looking at the caliper, we have graduations that go from 1 to 6 on this particular caliper. This is a 1 inch mark. Anything coming up to that is just 100 thousandths, 200 thousandths. So we read that like this: 0.1 hundred thousandths, 0.2 hundred thousandths. Then as we read on the dial, we have 10 thousandths, 20 thousandths. Each one of these increments is, so from dash to dash or line to line, is 0.001 thousandths. That's 1 thousandth of an inch, and so we're just adding that to it. So 10 thousandths, 15 thousandths, 20 thousandths, 30 thousandths, 40 thousandths. Right here would be 42 thousandths. So we're just adding those together. Remember, when we're measuring, I don't want you to squeeze on there. Don't try and force the dimension out. Just let it be what it is. Just lay the blades down on there. Just hold pressure on it, but don't push too hard. And just read what it says. Don't try and make a dimension read right, because just because you can make it read right doesn't mean that once it gets to inspection that it's going to be the same. So they're not going to try and force that dimension. All right, so that's just a recap of what we were talking about today.